Welcome to Global Chai Education, where we dive deep into the world of cutting-edge technology, gadgets, and innovations. Whether you're a tech enthusiast, a gadget geek, or just someone curious about the latest advancements, you've come to the right place. Hit that subscribe button, and let's explore the future of tech together. Today, we're taking a closer look at the DeepSeek R1, an advanced device designed for precise and powerful metal detecting. Ideal for treasure hunters, archaeologists, and hobbyists alike, the DeepSeek R1 offers superior depth and accuracy, using cutting-edge technology to locate metals in even the most challenging environments. Stay tuned as we break down its key features, performance, and what sets it apart from the competition. The release of DeepSeek R1, a new large language model from China, has caused a stir in the AI research community. A team in China released it last Sunday, and it's already making waves. Its benchmarks are close to OpenAI's R1 model in reasoning tasks, math, coding, and science. But what's interesting isn't just the numbers, it's how they got there. There are three key ideas behind DeepSeek R1 chain of thought: making the model explain itself; reinforcement learning, letting it train itself; distillation, shrinking it without losing power; chain of thought. If you ask most AI models a tough question, they give you an answer, but not the reasoning behind it. This is a problem. If the answer is wrong, you don't know where it went off track. Chain of thought fixes this. Instead of spitting out an answer, the model explains its reasoning step by step. If it makes a mistake, you can see exactly where. More importantly, the model itself can see where. The DeepSeek paper shows an example with a math problem. The model walks through the solution, realizes it made a mistake, and corrects itself. That's new. Most AI models don't do this. They either get it right or wrong and move on. Reinforcement learning. Most AI training looks like school. Show the model a problem, give it the right answer, and repeat. DeepSeek takes a different approach. It learns more like a baby. Babies don't get instructions. They experiment, fail, adjust, and try again. Over time, they get better. That's how reinforcement learning works. The model explores different ways to answer a question and picks the one that works best. This is how robots learn to walk. It's how self-driving cars learn to navigate. And now it's how DeepSeek improves its reasoning. The key idea is Group Relative Policy Optimization, GRPO. Instead of grading answers as simply right or wrong, GRPO compares them to past attempts. If a new answer is better than an old one, the model updates its behavior. This makes learning cheaper. Instead of needing massive amounts of labeled data, the model trains itself by iterating on its own mistakes. That's why DeepSeek R1 improves over time while OpenAI's R1 model stays static. Given enough training, it might even reach human-level accuracy in reasoning tasks. Distillation. There's a problem with models like DeepSeek. They're too big. The full version has 671 billion parameters. Running it requires thousands of GPUs and the kind of infrastructure only tech giants can afford. That makes it impractical for most people. The solution is distillation, taking a giant model and compressing it into a smaller one without losing too much performance. Think of it as teaching an apprentice. The big model generates examples, and the small model learns from them. DeepSeek researchers distilled their model into Llama 3 and Quen. The surprising part? The smaller models sometimes perform better than the original. This makes AI far more accessible. Instead of needing a supercomputer, you can run a powerful model on a single GPU. Why this matters? DeepSeek's combination of chain of thought reasoning, reinforcement learning, and model distillation makes it a formidable tool. It's not just about raw power. It's about creating models that are accurate, transparent, and accessible. If you're interested in AI, DeepSeek is worth paying attention to. It's not just another incremental improvement. It's a step toward models that can think, learn, and adapt in ways that were previously out of reach. The best part? You don't need to be an AI researcher to see its potential. The techniques behind DeepSeek are already being applied in real-world applications, from coding assistants to scientific research tools. And as these models become more accessible, their impact will only grow. DeepSeek R1 is important not just because of what it can do, but because of how it does it. Chain of thought makes AI more transparent. Reinforcement learning makes it more self-improving. Distillation makes it more available. If you want to see where AI is going, this is a good place to look. Summarize the DeepSeek R1 number 1. DeepSeek R1 is a new large language model developed by a research team in China. It's significant because it demonstrates performance comparable to leading models like OpenAI's R1 on complex tasks like mathematical, coding, and scientific reasoning. The model's innovations, particularly in using reinforcement learning and model distillation, could potentially make AI more efficient and accessible. Number 2. DeepSeek R1 uses chain of thought prompting by encouraging the model to think out loud or provide step-by-step reasoning in its responses. For example, when solving math problems, it will show each step of its work. Number 3. DeepSeek R1 uses reinforcement learning to learn through self-guided exploration, similar to how a baby learns to walk. Instead of being trained with explicit question-answer pairs, it explores its environment and optimizes its behavior by maximizing rewards. Number 4. Group Relative Policy Optimization, GRPO, is a reinforcement learning technique used by DeepSeek R1 to self-improve by comparing new responses with previous ones. Number 5. Model distillation is the process of transferring knowledge from a large, complex model, like DeepSeek R1 with its 671 billion parameters, to a smaller, more lightweight model like Llama 3 or Qwen. This makes the technology more accessible, because it reduces the computational resources needed to run the model. Interestingly, the smaller models sometimes even outperform the original larger model. Number 6. Model distillation makes high-performance AI more accessible by allowing researchers to create smaller language models that operate at a fraction of the cost without a significant reduction in performance. This enables wider use of AI technologies as it doesn't require huge computing infrastructures. This opens the door for smaller teams and individuals to run very capable LLMs. Number 7. By combining chain-of-thought prompting and reinforcement learning with GRPO, DeepSeek R1 achieves its high level of performance and self-improvement. So, what are the main takeaways from this video behind DeepSeek R1? The main takeaways from the research behind DeepSeek R1 are its utilization of chain-of-thought reasoning for improved accuracy, reinforcement learning with GRPO for self-optimization and increased performance over time, and model distillation to improve accessibility to powerful AI without requiring vast computational resources. These 3 innovations represent progress toward more efficient, accessible, and scalable large language models. 1. If you enjoyed the video, don't forget to give it a thumbs up. Thanks for tuning in, and I'll catch you in the next one, Chain of Thought.